Good morning. Today we're going to do a very simple experiment using HOA, the transparency platform for electricity generation, transportation, and consumption for the European market. You can see here that the HOA provides a number of data points for European countries in terms of generation of electricity, forecast, transmission information on outages, and so on and so forth. So the idea is basically to use an AI agent, to access the NSOE API, that's a public API, and to get the data points and use the LLM as a summarizer to get some insights on the current situation, for example, or on the forecast. For this, we're going to use the NSOE API. So, for example, you can see here the current generation for actual generation for Switzerland. Let me go to the right screen. Should be here. Sorry about that. So let's see. Maybe here. Here you can see there are some data for Spain, so the actual aggregated power generation using biomass, using fossil gas, using hydro, nuclear, and so on and so forth. So we can get all these data points through a simple API. Now, for our experiment, we're going to use the Strands Agents. That's an open source framework to develop agents. Using Strands Agents, you can access different LLMs like Claude or Bedrock or OpenAI and others. And we're going to use the multi-agent facility of Strands Agents, and we're going to use the agents as tools pattern. So basically, we're going to wrap the agent into a Python function so that we can call the function, and the function will call the LLM and get a result from the LLM. We're also going to use tools. Tools allows us to embed a Python function to be called by an agent. Basically, you develop a Python function and you put the tool decorator, and it's basically ready for Strands to be used. Let's look at it. So if I go to the tools, so as an example, I'm showing you how to get the current electricity generation for a certain country and for a number of hours back. We've put the tools decorator here. So first thing, we get the area code for the country code. We put a delay in the time if we want to. We define a time zone, and then we define the document type or the type of API we want to call, and which area call, and we give the period start and period end. So this function will be used by the LLM to get the generation, the power generation, the current power generation for a given country. If we go to the agent itself, so here, the agent itself, what does it do? It just basically, using the various tools that we defined. We've defined the tool electricity load, generation, day ahead prices, and so on. So all these tools can be used by our agent. I show you. A bit below, sorry about that. Yeah. So what we do here will basically instantiate an agent, a Strands agents, with a given model. The model can be, as I said, Anthropic or Bedrock or others, or even local models. And we give the agent a number of tools that it can use, like get country electricity overview, or get renewable energy forecast, get electricity load, and so on and so forth. And then when we call the agent, depending on the question, the agent will select the tool that he needs to use for a given question. All right. So let's try a simple Streamlit application that we developed. So this is the Streamlit application. Let's run it. So let's run the simple chat application that we've developed to interact with the electricity agent and to use the tools that we discussed before. So let me run the file, the Python script, and it will open a Streamlit application. So this is an application that's been developed using the Streamlit framework, and I can ask a number of questions. So for example, I'm going to ask, what is the current power generation in Spain? And then it will start fetching the data. So you can see here that my agent is getting the data from the API, right? You have a number of data points here, and then you have analysis that's been done. So if we go back here to the application, we can see the result. What is the current power generation at between 2 a.m. and 8 a.m. Universal Time. So we have around 7,000 megawatt nuclear power generated. We have some gas generated power as well, hydroelectric a little bit, solar power is ramping up, right? It's a sunrise. We have some wind power, but dropping. Winds are dropping, and we have some thermal or coal power generated as well. We can also look at the forecast. What is the forecast for Spain? Let me just correct. Yeah, here you go. So you can see here that we again get the data from the NSOA API, and then we call the Anthropic API, and then we get the result back from the LLM. So here it's still working. So let's see. So it's still getting answers from the LLM, and now we get the summary of the forecast. So there will be a morning ramp up. Of course, you're going to get the solar energy increasing in the morning, and then you'll have a peak around 42,000 megawatt, and then there will be an evening decline, and there will be a plateau, and there's a mix of solar and wind energy. All right, so the peak demand period is expected around 4 or 6 p.m. local time with 45,000 megawatt. And yeah, that's quite interesting. We can do that for different countries, and we can access different APIs, and then we can use a LLM or an agent to summarize the situation, to do country comparisons, for example. Thanks very much.